Hey, welcome back. I wanted to say a couple things about the beginning of Chapter 2. What you notice in the beginning of Chapter 2 is that we have lots of different statistical techniques that can give us estimates of the same thing we're trying to measure. And that may seem a little confusing, so I wanted to talk a little bit about why we have all these different numbers and how some of them work better in some situations and some of them work better in other situations. So imagine the following experiment. You're interviewing for a job. You're interviewing for a job at a company. Unbeknownst to you, this company's salary structure is very rigid. And what this company is, there are 12 people who work at this company. And 10 of them, 10 employees, make $40,000 apiece. And then 2 employees make $1 million each. That's the CEO and his son work at this company. Everyone else makes $40,000. These guys make $1 million. So you're sitting in your interview, and you ask the guy you're interviewing, probably the CEO, hey, on average, what do people make at this company? Now, he can tell you with a straight face that the average salary here is $200,000. And that sounds pretty good when you're sitting in the interview. But you look at this and you go, that seems crazy. No one here is making $200,000. But why is that so, right? If you add up all the money being made by everybody here, you've got 10 people making $40,000. So that makes $400,000. And then you've got 2 people making $1 million each. So that's $2,400,000. That's the total. That's the total amount of money being earned at this company. And how many people work at this company? Well, 12 people work at this company, so the average is going to be equal to $2,400,000, which split up among 12 people. So, okay, great. The guy was not telling the truth, not lying to you. This is the absolute truth that the average salary here is $200,000. It wasn't that he gave you bad information, it was that you asked for bad information. What you asked for was, what's the average salary? And he, with a totally straight face, can tell you it's $200,000. But if you had been given this setup, you would have realized, boy, there's no chance you're going to make $200,000. Unless you're one of these 2 people, you know how much you're going to make, and it's $40,000. So what would be a better way to measure this? Well, if you think about the 2 other ways we have to measure sort of the center of some data, we have the median, which says, okay, arrange your data in a row and say, all right, right down the middle, where's the 50%? 50% of people make less than this, 50% of people make more than this. And that would give you exactly what you wanted, because you have this list of how much people make, and that list would go 40, 40, 40, ... And then you'd hit your 10th 40, and then you'd notice 1,000K, 1,000K. And so if you looked at the data this way, you'd be able to look, oh, right here, the 6th guy, that's the median, that's 40K. So the fact that the median salary is $40,000, that's what you should have asked for in your job interview. Asked about that information. This is giving you a better picture of that. Or the other thing, you could have asked for the mode, which just says when I list the numbers, what number appears the most. Here it's clearly 40. 40 appears 10 times, and 1,000, 1 million appears only twice. So the mode, or the median in this case, would be a better representative number that you would want to know. What's a representative salary? What's a salary towards the center? But again, the guy didn't lie, he just misled you, and he misled you by choosing which statistic to tell you to make his company look more attractive. So the reason the average can be so manipulated is because it's skewed by these higher numbers. And this is true in general. In fact, this is true in general for income statistics. In general, if you look countrywide, the graph of income, most people make money somewhere down here, but a few very lucky people make money way up here. And this long tail, this right skew, means that for graphs with this shape, we are going to have the average will be greater than the median. So you will hear people in the news talk about both of these numbers. And the reason they'll pick which number to use is depends on what they want to argue for. So people who want to convince you that things are going well will tell you something like the average wages for a family of 4 is $75,000. People who want to convince you that things should change and that things maybe aren't going so great will tell you 50% of people in the United States, these families, make less than $60,000. So that's two different numbers, $75K and $60K. And again, neither person is lying. Each of them are picking the sort of statistics they want to use in order to further their argument. So I want you to keep this in mind as I have you work through your exercises in Chapter 2. Why do these numbers differ? Why might we choose one number versus the other as a way to represent our data? As we go further, we'll pretty much stick to the average, although I hope that the example I did first will make you remember to be skeptical of the average. So in the case I was talking about, where 10 people made 40,000 and 2 people made 1,000,000, we want to start thinking about how do we develop techniques so that we know to ignore those 2 millions. And we call those 2 outliers. So the next thing we'll be talking about is how do we deal with the data, even if there's some data points that we should ignore. So that'll be a topic for next time, and we'll talk about how to identify and eliminate outliers from our data. Anyway, I hope this was a helpful little rundown about the different ways that we can measure the center, and I'll be back next week to talk about quartiles and interquartile range. Thanks. See you later.